So this is one formula that we will be using. Okay. So this is one formula that we will be using, and the other formula is you know so also you can also write that find out the backward velocity. Sorry for this. So let me also add here one statement that find out the backwards velocity. So this is what we also will try to find out. Minimum backwards velocity required, or the design. Let me write design backwards velocity. Design backwards velocity. Okay. So we were talking about this formula here. So we'll be using this formula. But if you look at this formula, here you can see that we actually have everything. We know the value of E. We know from Ds is the loading rate, and psi value is given. G is known. Now D is not only a single value. Then we have here number of values for D. So we have lot of values. Okay. So if I have number of stratifications in the bed, so that different sand sizes will cover certain part of the bed, and if this is, let's say, Li, and and then this is the total bed depth is L. So then so particular suppose Di particles sand size is actually having 20% of the total length. So in this word we can say Li depth is covered by Di size of the sand, and the total is L. So we can actually write that for this particular strata, the head loss, let's say HLI. So HLI, so look at this formula. HLI equals to F dash 1 minus E by EQ, and you have VSS square, which is common for everything, and you have psi, which is also same for the whole bed, and also G is the same for the whole bed, which is now changing. So I'm taking the L on the other side. So you can see we have Li divided by you have Di. Okay. So this is the head loss through only this part of this bed. So this is for HLI is the head loss. So the total head loss is equals to HL, which is the summation of all the HLIs. Okay. So this is the summation of all the HLIs are there. Let me separate it again. Line. So all the HLI will be summation, and then what you get is this part is kind of same for everyone. So I can write actually this F dash, if you look, not, and actually this F dash is not also same for everyone. Now you can see F dash is equal to 151 minus E by RE. What is RE? You can see RE formula also has the D incorporated in it. So for each layer, this F dash value will change. So what we should actually write is that you can make this little change in your formula that I have written. So this F dash actually is a function of the D. So we will write F dash I here. Okay. So this is F dash I for this particular bed. So we have a different F dash for this F dash I. Okay. So now if we try to write this formula now, you can see that 1 minus is a constant for all these beds. So E is the constant and Vs square is the same. So psi is the same. G is the same. Now, you know, so you have to have the summation of F dash I L I by 1. Okay. So this is, when we have a stratified weight, then your total heat loss is given by this. Okay. So we will utilize this, particular form when solving our, this equation. So let us, problem. So let us get back to this problem, and we will use this HL equals to HL equals to E by 1 minus E Q. 1 minus E by so this is 1 minus E by EQ. Okay, and we have Vs squared by psi G. Now we will have F dash I L I by L. Okay, so and this is the summation. So this is the formula that we are going to use. Now I will show you how you can use this, but in a spreadsheet. But before that, let me try to write other stuff here. So psi value is 0.95. Okay, and let us also convert this 175 ds into ds into meter cube per second per meter square. So this is 175 meter cube per meter square per day. So we want to convert it into meter per second. So if you want to do this, yes.
Sir, how this formula for HL came? Please repeat.
You want me to repeat this? Okay. So you can see here, this HL by L is F dash into 1 minus E by EQ divided by into PCBS square by psi D into G. Now, if you look at F dash, so if we have different layers, so this is for one particular particle size D, right? But if we have a bed where different values of Di are there, and so it corresponds to a certain length of the bed. So this is the situation. You have Di amount size of uh, sand with a depth of Li, and all these Di's, they can if you sum them up, it is the total length. So Li is the depth of or length of this particular layer. Now all these layers, if you add, this will become the total length, right? So I want to actually, and in each depth you can see each size, the F dash value also changes, because if you look at RE is Reynolds number is a function of also our you can see here the value of E here. So for each of these layers, RE value is going to change. So and so if RE is going to change, F dash is also changing. So what are actually constant in this bit? So 1 minus E by EQ Vs square by psi into G. So these are terms are the constant, but what is varying is Li, F dash, and Di. So this will be varying. So what I we wrote it like this: 1 minus E by EQ Vs square by psi Z F dash I Li by Di. So if we sum this everything, then we get the total heat loss HL. Is it clear?
Yes.
Okay. So now let us find out what we were doing. We were trying to find out the value of Vs, or you know, so this is what we want to find out in uh, meter meter per second. So we have meter square, and we have 1 day. So you have 24 hours in 1 day, 60 minutes by 60 seconds. Okay. So let us try to find it out. Can you find it out for me? That's my mobile phone. Okay. So 175 divided by 24 divided by 60 divided by 60. So you get 0.0000. So 0.0000. There is something I am not right. Meter per second. Okay. So this is our Vs, and so if I write Re in terms of V, so you have rho Vs, and look at this formula: rho Vs psi by mu into V. So if you get back here, rho Vs psi by mu into V. Okay. So I'll write REI equals to AR. Okay. And if you write rho is take 1000 kg per meter cube. Okay. And you have Vs is 0.0020 and psi is 0.95. It is given here explicitly, and divided by mu. Mu is your 1.3 into 10 to the minus 3 kg meter second. So you can write 1.3 into 10 to the minus 3 kg meter second, and this is multiplied by di. So can you please calculate it for me? So this is 0.0020 times 0.95 divided by 1.3. This times 1000 times 1000. So we have 1461. So we have 1461 into dr. Okay.
Sir, is 745?
It is 745. Okay.
745.38.
Okay.
Sir, it's 1461.53.
Okay.
1461.53.
Okay. ठीक है 1461. Let us write 1461. And let us now get we have probably everything. E is 0.5. Okay, and what else? We know almost everything. Here, let us go to okay. Specific gravity of sand is 2.65. So rho of sand is 2.65 per thousand. Okay, so sorry, 5. I got 5. Okay, 2.65 into so this is 2.65. Okay, so now let me enter, let me open up a Excel sheet. Okay. So I have opened up an Excel sheet. Can you see this?
Yes, sir.
Okay. Now you can see that I have entered this, values, 0 to 20, 20 to 40, 40 to 60, 60 to 100, and lower shift size and upper shift size and all these things. Okay. Now let us try to start this thing, our work. So, first let us write, we need to find out mean uh, size. Okay. Uh, Mean size, let's write D here, uh, or DI, you can say, in millimeter. Okay, in millimeter. And all right, and the formula for this, when we write this should be okay. So we will normally, it is from a probability based paper. So we will write DI is, root over of D1 into D2. So I don't want to get into the nitty gritty of this thing. You must be knowing this, from your soil dynamics classes. Right. So now let me enter this formula here. So equals square root of D1 D2. Okay. Right. So I got this. And for all these rows, I'll just use this, and this will be, done, right? Okay. So let me show only significant values here and make it simple. Now let us calculate from every D. We will calculate RE, right? And we have, if you can see this thing, we have calculated that REI equals to 1461 into DI, where DI should be also in, here DI is in millimeter. We also have to convert the DI value in meter, because all we are doing in meter. Okay. So let us write down RE, okay, and this is equals to 1461, okay, times DI, but DI is in millimeter, so I will convert it into meter. So divided by 1000. Okay, this is our value of RE. So let me also write here RE equals to, this is what we did. RE equals to 1461 into DI. Now DI should be in meter. Okay, so you can now understand why we do this. Okay, so now let me calculate this RE for everyone. All right. Now next, if you look at this formula, we want to find out the value of, if you look at this formula, we want to find out Fi dash Li dash by Di dash. So we want to now find out Fi dash. Okay. So let us try to do that. So if I dash, let's write f dash. Okay, but here I cannot really write dash here. So let me write f dash like this. Okay. Now, so we know f dash equals to, so if we know f dash equals to 1 minus e by re into 150 plus 1.75, right? And here we know e equals to 0.5, so we can write 0.5 divided by re into 150 plus 1.75. Okay. So e equals to 0.5. Fine. So I can now write the formula for f dash. Sorry. So this is equals to 0.5 divided by RE. RE is this cell, okay, times multiply by 150, then plus 1.75, right? To end the parenthesis here, and that's it. Sorry, 0.5 divided by RE into 150, 1.75. Fine. Okay. So let us find out all these values. Okay. All right. Now let us now, if you go back to this equation, you see what is left here, Li by di, right? So we want to really find out Li by di, and Li is nothing but we have. So let us write down Li by di. Okay. Let me write down here caps so that Li by di. Okay. So how to find out that? The way you find out that is so what is this Li? You can see this is all this 0.2, right? So here this is 0 to 20%, 20 to 40%, or this is stratified weight of 20% in each this thing. So I write for 20%. This is 0.2. Okay, is the this is 0.2 of the total weight. I'm just trying to write so 0.2 times 75, right? Sorry, 0.75 meter. Why 0.75 meter? Because you can see here we have said that the depth is 0.75 meter. Total depth is 0.75 meter. Okay, so let us write 0.75 meter here. So 0.2 into 0.75, this is the total depth, right? So this is 20% of, and so this is the Li value. Now divide it by di. What is di? Di is this is in millimeter. Okay, so we have to convert it into uh, meter. So multiply with 10 to the power or divide it by 1000. Okay, so divide it by 1000. All right, so with me. All right, so we have found out Li by Di right here. So this is our column. Okay, now we have done everything, and what we need to do, we need to now find out, f dash, into Li by Di. So if you look at this, we have f I dash Li into Di. So let me try to do that. So we want to find out f dash um, into x Li by Di, right? Li by Di. So we want to do that. How to do that? Well, I'll just multiply these two columns equals to this one multiplied by this. Okay. So this is the value that you get, and then you sum them up, and this is the summation that you are getting. Okay, let's write total or the sum, and then uh, equals to sum of sorry equals to sum of all these values. Okay, so this is what you get. Now what we actually got from here is sigma of Fi Li by Di. This is what we got. Now we have to find out this, we have to multiply with this. So let us try to do that. We need to also check the calculations. I'm not sure whether okay, so let me check these calculations. Okay, now let us do the calculation here. So we got this x. Just let me check this calculation once again. So this is 0.2 and 0.75 meter. We have divided by meter. RE is fine. F dash is RE, the function height. Okay. Li by Di. F dash xi. Fine. I think we are doing okay. And so we got this summation value there. So if I now want to do this, so we want to find out the value of HL from the chart. So HL equals to 1 minus E 0.5 divided by 0.5 cube, okay, into Vs squared, which is 0.000 square, okay, divided by psi is 0.95 divided by 9.81 times your Fi Li by Di value is 83,290.67. Okay, so let us write here 83,290.67. So this value sigma fi dash del I by di is equal to 83290.67. All right. Now let us plug in this number and find out where we are. So we have 0.5 divided by uh, so we get this value. I get this value as 13.76 meter.
लगा रहे हैं गेंद उठला पूरा निकाल रहे हैं.
Okay. So please also check from your end. I'm not sure whether I have doing the same thing as you are doing. Okay. All right. Any question on this?
Sir, F dash is a drag force or any other force, sir?
Please repeat again.
Sir, F dash is drag force or any other force, sir?
F dash is the coefficient. It's a I would say it's it's a relationship between it's a drag force. It's not a drag force. We use as the relationship between just a coefficient here. Or we can say this is a friction factor. That will be a better term. So if dash
Is it Darcy-Weisbach equation we use in fluid mechanics to calculate?
Darcy-Weisbach equation, this is the Darcy equation. If you see how we found out these values, so this is F, which is coming from this Darcy-Weisbach equation. So you can see this F is from Darcy-Weisbach equation here, and then so this F has now for this filter, this has been kind of modified into this form. So F dash is really the friction factor that we have calculated. Friction factor for moving this water through this filter bed. Okay. Now I would, as I have shown you how to calculate this thing, I think you now can do it by yourself. Only thing is that I'm little bit skeptical about the unit that I have used. So I will probably come back and will say, because itna heat loss, the value that we have got is little too high. Probably we are missing some. You know, I mean, normally filter is operated when the head loss is about uh, 1.5 to 2 meter. You know, clean bed head loss should be around 1 meter or so. So I think I have just check the calculation by yourself again. So I think this will be 1.376 meter uh, rather than 13.76 that I have got. So please check at your end, and I will also check my calculation once again, and we'll come back to you. Okay. Maybe I'm trying to have some error in my units. I'll come back to you, later. But right now, let me move on to the next part of this question. Find out the design backwards velocity. So you can see, find out the design backwards velocity. For this, we will resort to this equation that we discussed in the last class. The backwards hydraulics part that we discussed, and we actually found out some, we came up to some equation here, REMF, and then we actually found out that this is one equation. REMF is given by 33.7.
Sir, maybe in previous part we have used porosity of bed as 0.5, but in equation we have to use a wide ratio.
Excuse me.
We have changed. So we have changed porosity in the terms of wide ratio.
We have changed the porosity in terms of
Wide ratio. We have to change. In question, porosity is given.
with respect to wide ratio.
Yes, sir.
So you mean to say when E is the wide ratio that we use, right? No, porosity. E is the porosity, right? Porosity is pore volume per unit volume of the bed, right?
Okay.
So when we say E is E, we say it's a porosity of the bed, right? Normally, आपका book में, in your book probably E is defined as a wide ratio. So that's why this confusion is coming. Here I am just saying E is a porosity. All right. So anyway, let me get back to this part. So we can say that we have found out how to find out the minimum velocity for the backwash, and you can see this is nothing but equals to mu REMF by rho d, where d is the diameter, and if you can find out EMF REMF, that will help us to find out the value of VMF. Now, how REMF can be found out? This is the formula that we have come upon, with respect to the Galileo's number. And what we defined as Galileo's number is d cube rho minus rho s minus rho g by mu square. Okay. So now what we want to do, we will again come back to our Excel sheet and try to find out the value of GA, and from GA we'll try to find out the value of we'll try to find out the value of REMF, and when you find out REMF, you can find out the value of VM. So let us go step by step here. All right. So next, let us try to find out, write down the value of GA. Okay. So Galileo's number, and for your understanding, Galileo's number is given by this. Okay, so Galileo's number, let me write down the term for Galileo's number. So Galileo's number GA equals to dq rho into rho s minus rho g by mu square. Okay, so let us enter this formula here. So you have d is this. Okay, so let me write, just try to follow the way I'm writing. So this is d. Okay, and we need to this okay, so this is our d, and I have to raise it to the power q. So this is q. So okay, so this is dq, and now into rho. Rho is how much? 1000, right? 1000 multiplied by rho s minus rho w. What is rho s? Rho s is 2650, right? So we will write 2650 minus rho is 1000. Okay, and then you have to multiply. Then we have g, which is 9.81. Okay, now divided by mu square. Mu is 1.3, and 10 to the power minus 3. So minus 3, and this will be whole will be understood. So this is the formula that I have entered for GA. Okay. All right. So there is an error in the formula. Let me write out F4 then go minus 3 Q, okay, into 1000 into 1000 minus 8.9.81 divided by 1.3 square. I think I'm doing it correctly. Now this 9.81 has a problem. It shows that 9.81 has a problem. So, and this is, let me put a bracket here, extra bracket right here, and then try to enter. Okay, so this is correct. I have corrected this formula, and then let me find out for other ones. Okay. Now we want to find out RMF. Okay, so we now need to find out RMF, and RMF, what is the equation? Let us see this equation. Equals to 33.7 and 2.0041 into G. Okay. So let us write down here the formula. So we have 33.7 7 square plus 0.0408. Okay, okay. To the power 1. So this was the formula. Alright, so let us write RMF and let me enter the formula. So we have 33.7 plus 0.0408 times GA is this column, okay, and you have whole to the power 0.5, right, half. So that means gives me RMF, okay. So this is RMF, okay. Now we want to find out BMF. So let's see BMF equals to mu into RMF divided by rho divided by T. Okay. So let us write down here. BMF equals to mu RMF by rho T. So BMF equals to rho RMF. Mu RMF by rho. Sorry. Mu RMF by rho. So you can write down here. We can so BMF equals to mu is 1.3 times 1 minus 3 and by RMF is this one divided by rho is 1000 by T, right? So let me write it like this: 1000 divided by D in meter, right? So we have to write this D here times 10 raised to the power minus 3, and you end the bracket here and this. So okay, so you got this value of BMF, okay, and you find this out, and this is in meter per second, okay. This is the value got in meter per second. So we need to find out in meter per day. So meter per day you have multiply with, meter per hour, so you multiply with, so you multiply with this 600. So this is like this. So you can see that we have different values for BMF, okay, and you get the highest value of it, okay. Just a minute. Sorry, I missed something here. So I had here minus 33.7 here. The RDMA formula we have minus 33.7. Sorry about this. So we had this formula minus 33.7. So you have to do it like this. Equals to minus 33.7. So when I do this, everything gets changed, and you have this number 19.63. Sorry, we have 0.0. Alright, so we get this number 19.62 as the highest velocity that you need to provide. So you get this one. Let me, so this is the one that we will use, and your design backwards velocity would be 1.3 times of this. So your design backwards velocity, design backwards velocity is 1.35 times this velocity here. So this is 19.69 meter per hour. So you can find this value. And so as you know, the design backwards velocity or BW, so you can find out the filter. If you have this area, cross-sectional area of filter is A, then you can find out backwards flow rate equals to VW. Okay. So this is how we can find out this. If you look at this equation, this problem, we can actually find out a solution for this problem using this particular formula. Now, as I have said, all these columns, now you can actually change these values and can make it like a program where it automatically calculates everything. Although I have written all these things here, you can also make it a part of your program, using which you can find out your filter dimensions and everything. All right, fine. So I will upload this slide after this class. Today I have another class running in 2 minutes from now. So and this is what we had to discuss about filtration. From the next class onwards, we will start discussing about membrane-based filtration. This was granular filtration. We'll start discussing about membrane-based filtration. Okay. Meanwhile, I'll upload this slide here, also this Excel file. Now please check if I have done any mistake in my calculation, because the value is, the head loss value is coming rather high. I will also have a look, but I will ask you to also have a look and come back to me if I have made a mistake or not. Okay. All right, that's for today. I will see you
Sir?
guys. Yes.
Sir, some last slides of sedimentation part ahead of slide number 15 are not there on Teams, I think. So could you check that too, please?
Last slide of
Some last slides, sir. Sedimentation part, yes, sir. The topic sedimentation slides of topic sedimentation are not there on Teams. They are up to slide number 15. The
okay,
part
the
where you
one I have
discussed.
uploaded.
Yes, sir.
All right. So this is the last one, I guess.
Yes, sir.
Okay.
The design problem you discussed is not there. Yes,
Okay.
sir. This one.
All right. So I will upload this also. Okay. Fine.
Okay.
I will upload all these files. All right. Okay. Thank you for being with me, and I will see you guys on Wednesday, I guess, because Monday is a holiday, right? So I'll see you guys on Wednesday.
Thank you. Thank you very much.
Yeah.